Wall Street spends millions on research teams to analyze the stock market. I solved this problem for myself by building an AI team of financial experts using OpenAI's Agents SDK, and it generates profound investment reports in minutes. Today I'm sharing the complete blueprint of how this framework works and how you can build multi-agent systems too. What exactly is the OpenAI Agents SDK and why should you care about it over other agent frameworks? The Agent SDK is OpenAI's production-ready upgrade from their previous experimental swarm project. It's built around three primitives that are simple yet powerful. First, you have agents, which are just LLMs with instructions and tools. Second, handoffs, which let agents delegate tasks to other specialized agents. And third, guardrails, which validate inputs and catch errors before they break your workflow. It has a Python-first approach. That means instead of learning new abstractions, you just use normal Python patterns to orchestrate everything. If you want to chain agents together, you can use regular Python functions. For parallel execution, for example, use async. The agent loop is completely automated. It handles tool calls, LLM reasoning, and workflow control without you having to manage any of that complexity. You can either let the LLM decide which tools to use in auto mode or force specific tools when you need deterministic behavior. For collaboration, you get two patterns: handoff collaboration, where agents can pass control to each other mid-conversation, or the agent as a tool pattern, where a manager agent orchestrates everything by calling sub-agents like regular tools. Every Python function becomes a tool just by adding a decorator. You don't need to write schemas. Plus, you get full MCP support and OpenAI's managed tools out of the box. Everything is automatically traced in OpenAI's dashboard. Every agent call, every tool execution, every handoff is visualized so you can debug and optimize your workflows instantly. You can even generate so-called graph width diagrams of your agent flows. Let's get right into the implementation. So here we have a flow chart of the architecture of the portfolio research team. And at the top, we have the head portfolio manager agent, and this one orchestrates the other sub-agents. And we have four in total: a fundamental analysis agent, a macro analysis agent, a quantitative analysis agent, and report editor agent. The specialty is that these three financial agents, they are called in parallel, and they can be executed in parallel using the Agents SDK, which makes it much faster to run. And then in the end, when they report back to the portfolio manager, it's calling the report editor agent, which is responsible for generating the investment report. The fundamental analysis agent has the web search tool and Yahoo Finance MCP available. The macro analysis agent has the web search tool as well, plus uses the thread API, which I will show you in a minute. The quantitative agent can run the code interpreter. It's an OpenAI built-in tool, the Yahoo Finance MCP, and also fetch thread data. And yeah, the report agent can write a markdown and also generate a PDF. This whole system was inspired by the OpenAI cookbook. They have a very similar example, but I enhanced it with more tools and a Streamlit UI. So in the end, you will have this UI. You can type in your prompt. You can select your risk awareness level and click this button. Then the whole system is running and then returning you a markdown and PDF report in the end. What I also wanted to cover is why this architecture is so beneficial. So first of all, like I said, running all agents in parallel makes it much faster to run. Then in general, having a multi-agent system increases the quality because we don't overload one agent with too much information with extremely long prompt. Instead, we separate each concern into one agent with separate tasks. And this makes it also much easier to optimize later on. We can exactly measure the inputs, the outputs, and it's more modular. We can add new agents, we can remove agents, we can swap tools, we can edit prompts and instructions of each agent. And yeah, this makes the system very beneficial. So let's walk through this code and show you how I built this. So first of all, you need two API keys. First of all, I use the thread API key, and this is like macroeconomic data coming from the Federal Reserve Bank. You can create an account, link is in the description, and then you head over to API keys, and here you can then request a new API key. You will see it here, and you can copy it and paste it in your code base in the .env file, like I did it here, thread underscore API underscore key. And we do the same for the OpenAI API key. For that, you head over to the platform.openai.com and click on create new key, and then you copy the key and paste it here. So I will just walk through a part of the code base right now. I uploaded it to GitHub. Link is in the description, so you can download, check out the full code base yourself. I defined all the tools for these agents here in the tools folder. For example, we have the write markdown tool, and this is basically just a normal Python function with inputs and with an output. And the only thing we have to do is really adding this decorator here. And this turns it into an agent tool. And this comes from the OpenAI Agents library, here this agents module. So another, a bit more complicated example is the Yahoo Finance MCP. So we use that MCP server to fetch current up-to-date information about stocks and companies, balance sheets, historical stock prices, and so on. And this has like more than 500 lines. This comes mostly from another open source repository. So someone already built the server for Yahoo, and this is mainly copied here from this repository. And the only thing that I added are some helper functions here. So the data we receive from Yahoo, we save this to files, to CSV files and to JSON files, depending on what data we get back, so that our agents can then read it, or other agents can read it in the end, and we can create a report. Yeah, and why is it so much code here? You maybe think, okay, I saw MCP server integrations before, super easy, just 3-4 lines of code. Yeah, these are like examples where other people have already hosted the MCP server somewhere, and you just call a remote MCP server. So in this case, everything is running locally. So we have full control of what's happening, what APIs are called, and this is basically the source code of this MCP server, if you will. So we have several more tools defined here, and another core piece of this system are the prompts. So I would actually say the prompts are like the heart of the system, and we have a special instruction for each of these agents, and we also have prompt for the code interpreter and a tool retry prompt, where we just define like when it should retry tools. For example, here, this fundamental base prompt is for the fundamental analyst. So, I mean, this is like basic prompt engineering that we apply here. So first of all, we give it a role, right? You are the lead fundamental analyst at a hedge fund. We define which tools it can call. and that it should call all tools parallel. For example, we give it some examples here, then what the task is of this agent, the requirements, when using these different tools, then kind of the process, how it should think, so the steps. So first of all, it should decide which metrics are most relevant to the user's question. Then it should create a plan, then it should act, and then in the end should reflect and review before returning the final response. And then we also say here what the final report must include. Yeah, and in the end we close with end of section. So this gives kind of a signal that the turn is over for this agent, and then it's reporting back to the main orchestrator manager agent. Yeah, and these other agent prompts are very similar from the structure besides of the portfolio manager prompt. So here we tell it which specialized tools it has, and in this case these tools are these other agents, these other three agents. It should call in parallel, and then in the end it should finalize with the report editor. Then we also have the tool usage rules here with examples and what it shouldn't do, and the workflow, additional guidance, additional examples. When we have the tools and prompts defined, then we can continue setting up the actual agents. And I have this all grouped here under the financial agents. And let's take, for example, the fundamental agent as an example. So this is not that much code anymore because we import everything that's needed. So here, first of all, we import the prompt, and this is just a helper function. Then we import the Yahoo server. This needs to be started before the agent can use it. This agent class here, this comes from the SDK, and this is all defined, like the available parameters, like the name, the instructions. This is the prompt. Then we import the MCP server here and the available tools, and we give it a web search tool. The web search tool is imported directly from the SDK. This is an OpenAI managed tool. We can optionally set the search context size here. That means that it's just searching like a medium amount, and there's also a large and small, and we define this in our settings. And also the model, which model to use, this is also coming from the settings. And here we set in the model settings that it should call all tools in parallel. So when I go to the settings here, you see I just bundled everything here in one place. So the default model, I set it to 4.0 mini, but this can be overwritten via an environment variable. Then we can set a different model for the portfolio manager and also for the code interpreter. This is like the default search context, small, medium, or large. Then the Yahoo MCP timeout that we can set here, and also how many turns we want to allow in total. Let's look as well at the quantitative agent here. The structure is the same. We just input different tools here. So we give it the code interpreter tool, the thread tool, which fetches the macro data, and then it can read the files and list the output files. Yeah, and the portfolio manager agent is a bit different because this is the agent that orchestrates all the other agents below it. And the difference is that we are using the agent as a tool pattern here, and we're giving it all the agents that we have as a tool. And we also have the run all specialists tool, which bundles the three main agents here. And the rest is just the definition here and the import of these agents. And yeah, what we want is that in most cases, this portfolio manager agent is firing off all of these three agents in parallel. And then after you got the data back, then it's calling the report edit tool to create the investment report. So how do we run this all now together? We have a config file here where we bundle now all of these 4 main agents. And then we have here a research workflow file where we basically import it here and then put it into this runner function. So this runner.run method, this comes from the SDK, and this basically kicks off the entire workflow. And then I connected that to a Streamlit UI. I just, that's very easy to just AI generate if you have the rest set up.
What? Bro, what are you talking about, man?
And we import the research workflow here, and in the Streamlit UI, when you press the button, it's kicking it off here, and the full question is a parameter of this. Yeah, and these are just the Streamlit UI elements that we define here, plus the markdown output with download button and the PDF download button. And to run this now, we type Streamlit run and then the file name of our Streamlit app definition, press enter, and then it's spinning off and starting the app for us. And what I'm about to show you right now is not financial advice. Yeah, I have to say this disclaimer, but just to show you what you can do with this app. And I came up with some example questions. Let's prompt it, for example, is NVIDIA, yeah, this is the ticker of NVIDIA, overvalued at current levels considering its AI revenue growth and competition?
Whoosh, like that. Whoosh. I am the sound effect.
Let's leave it at medium, our risk awareness level, and let's click on Run Research. And when we look at our code, in the meantime, we should see also some logs here. These are the logs actually of the Yahoo Finance MCP. So we see that it's searching the stock info for NVIDIA, recommendations, financial statements, the stock actions, the news, holder info. So it's pulling all the data from Yahoo. Yeah, this takes now a few minutes. So let's just wait and see what we'll get. Our agent team ran successfully, and we see now we got a preview here of the report. And if we scroll down, we see we can download the full report here in Markdown and also the PDF report. And we see here executive summary, fundamentals perspective, the macro perspective, the quantitative perspective, and then it's also able to output some charts. In this case, it only generated one chart. We will try another example, and we see some numbers here. Also, what the analysts are recommending, portfolio manager perspective here, in some recommendations and answer to the question, and of course our disclaimer. Let's give it another try and ask it something simpler. Should I buy a Tesla stock right now? Our risk awareness is low, and let's hit research again. By the way, one run costs about 20 cents using the GPT 4.1 mini model. So, I mean, there are cheaper models, could be lower, could be also higher, depending on, yeah, what model you use. I mean, we could use the normal GPT 4.1. We could use the O3 reasoning model just for the portfolio manager, and we will probably get a better output, right? And what I can show you in the meantime now is when we go to our OpenAI dashboard and to the traces here, then we see, yeah, all the logs actually. So we can see here the last agent we ran that it called 25 tools, and the execution time of this. And we can see in detail like what it actually did. So here we see at the top the head portfolio manager agent, and then it called run all specialists in parallel. And here we see, for example, what kind of prompt it gave and guidance it gave to these sub-agents and then the output it received later on. You can see the macro analysis agent, what it did. It called the get thread series tool, and then the quantitative analysis agent, which called a lot of these Yahoo tools, and so on. And in the end, we should see here the report editor, which read all the files and then it wrote the markdown and then it generated the PDF. Okay, so the research is completed for Tesla. We got a complete investment report now, and let's open up the PDF as well. And it's a similar structure that we can see here, embedded data and charts. And we got a bunch of more charts here. Nice. So we see the daily returns here, the 30-day moving average of closing prices, then the volatility and also the volume and volume spikes here of the past, almost the past year. Then the distribution of analyst ratings. Yeah, so to sum it up, what are the pros and cons of using the OpenAI Agents SDK? I used other frameworks before, for example, CrewAI. You actually find a video on my channel about that, where I also go through an example implementation. So in my opinion, the Agents SDK is for building high quality, production ready multi-agent systems. It's battle tested by OpenAI internally, so that's definitely a plus. You can use the OpenAI internal tools, for example, the web search and vector store, code interpreter, which work really well. So next, it is open source, so you don't have any vendor login, and you can use this completely for free if you want. Another plus, I think, is the included tracing. So as well, without any extra setup, you can use the OpenAI tracing dashboard, which gives you a lot of information, makes it easy to optimize and to debug your agent system. So what are some of the downsides of this framework? So first of all, it has definitely a steeper learning curve. It's not made for beginners or for non-developers, and definitely more difficult to use than CrewAI, but it comes with much more features and much more options to customize it. Another point is that it still has a lot of dependence on OpenAI. So it works really well using OpenAI models, but if you don't want to use any of the OpenAI tech, then yeah, you have to use different tools for web search, for example. You have to set up your own vector store, and you also have to disable the tracing dashboard. But I mean, there are options. You can use a lot of different LLMs, and you can also use and plug in your own tracing solution. Lastly, I mean, there's just some privacy concerns that I see when you use the traditional stack and all the OpenAI models and tracing, because it's all running on OpenAI servers. I mean, that's just something to consider if you, depending on your use case and what you're building, if you want to have all this data on their servers. Yeah, so that's about it. The link to the full code is below in the description, and just drop me a comment if you have ideas what I should build next. And I hope you enjoyed this video. See you in the next one.